How do polar stratospheric clouds destroy the ozone layer? Imagine a winter sky over the polar regions filled with strange, wispy clouds high above the Earth's surface. These are polar stratospheric clouds, and they play a surprising role in thinning the ozone layer. During the cold polar winter, temperatures in the stratosphere drop below -78 degrees Celsius, creating the perfect conditions for these clouds to form. They usually appear between 15 and 25 kilometers above the surface. These clouds are not like the ones we see in the sky during the day. They are made of tiny ice crystals and sometimes contain nitric acid and sulfuric acid droplets. There are two main types of these clouds, one made mainly of ice crystals and another with nitric acid and sulfuric acid. The colder the temperatures, the thicker and more extensive these clouds become. Now, here's where the magic of destruction begins. Polar stratospheric clouds act as surfaces for chemical reactions to happen. Normally, most chlorine in the atmosphere is locked in stable compounds like chlorine nitrate and hydrogen chloride, which do not harm the ozone. But when these clouds form, they provide a platform for these stable compounds to react. On the surface of the clouds, chlorine nitrate and hydrogen chloride react to releases reactive chlorine atoms and chlorine monoxide. These reactive chlorine particles are very good at breaking apart ozone molecules. When sunlight returns in the spring, it energizes these chlorine radicals, causing them to rapidly destroy ozone. This process is what causes the famous ozone hole over Antarctica each year. The clouds also remove nitrogen compounds like nitrogen dioxide from the stratosphere through a process called denitrification. Normally, nitrogen compounds help deactivate chlorine radicals, but when they are removed, the chlorine radicals stay active longer, leading to more ozone destruction. The formation of these clouds depends heavily on the extreme cold temperatures of the polar stratosphere. If the climate changes and the stratosphere cools further, it can lead to more cloud formation and more ozone loss. Conversely, warmer temperatures can reduce cloud formation and lessen ozone depletion. So, these clouds are a natural part of the seasonal cycle, but human-made climate change can influence how much damage they cause. In short, polar stratospheric clouds set the stage for chemical reactions that turn harmless chlorine compounds into powerful ozone destroyers. When sunlight hits these reactive chlorine particles, the ozone layer takes a big hit, especially over the polar regions.